On September 5, 1977, NASA launched Voyager 1 aboard a Titan IIIE Centaur rocket from Cape Canaveral. What began as a mission designed to study the outer planets would eventually become one of humanity's greatest journeys into deep space. Voyager 1 was built as a sophisticated robotic explorer equipped with cameras, spectrometers, magnetometers, and instruments designed to investigate particles and radiation. Its primary objectives were Jupiter and Saturn, but the discoveries made during those encounters transformed our understanding of the outer solar system. When Voyager 1 reached Jupiter in 1979, it returned detailed observations of the giant planet's atmosphere. The spacecraft revealed complex cloud structures, enormous storms, and powerful atmospheric activity surrounding the famous Great Red Spot. One of its most remarkable discoveries came from Jupiter's moon Io. Voyager detected enormous volcanic plumes rising hundreds of kilometers above Io's surface. These eruptions demonstrated that active geological processes were occurring on a world other than Earth. Io became one of the most volcanically active bodies known in the solar system, changing scientists' understanding of how moons can evolve. Voyager 1 then continued toward Saturn, arriving in 1980. The spacecraft studied Saturn's spectacular rings in unprecedented detail, revealing intricate structures and patterns created through interactions between the rings and nearby moons. But the most important target of the Saturn encounter was Titan. Titan possessed a dense atmosphere dominated by nitrogen and containing complex organic compounds. Its thick orange haze prevented visible light cameras from seeing the surface clearly, but the observations established Titan as one of the most intriguing worlds in the solar system. After its Titan encounter, Voyager 1 was sent onto a trajectory that carried it away from the planetary region and toward the outer boundary of the Sun's influence. For decades, the spacecraft traveled through the heliosphere, the enormous region influenced by the solar wind and the Sun's magnetic field. Then came one of the most historic moments in the mission. On August 25, 2012, Voyager 1 crossed the heliopause, the boundary separating the heliosphere from the surrounding interstellar environment. At a distance of more than 120 astronomical units from the Sun, the spacecraft entered a region that humanity had never directly explored with a functioning probe before. Measurements indicated a dramatic change in the particle environment. Solar origin particles decreased while higher energy cosmic rays from outside the heliosphere became more prominent. Voyager 1 had become humanity's first spacecraft to reach interstellar space. The achievement was extraordinary considering the spacecraft had been designed and launched in the 1970s. Even today, Voyager 1's signals must travel enormous distances before reaching Earth. The spacecraft communicates through NASA's Deep Space Network, whose large antennas receive incredibly weak transmissions from the distant probe. Voyager's instruments have continued to provide valuable information about the interstellar environment. Its plasma wave instrument has detected oscillations associated with the surrounding plasma, giving researchers another way to study the extremely thin material between stars. The spacecraft has also encountered disturbances generated by powerful solar events. When waves and shocks from solar eruptions travel outward through space, they can eventually interact with the interstellar medium, allowing Voyager to measure how those disturbances behave far from the Sun. But keeping such an old spacecraft alive is an engineering challenge unlike almost anything else. Voyager 1 is powered by radioisotope thermoelectric generators. These systems convert heat produced by radioactive decay into electrical power, but their available output decreases gradually over time. Engineers have therefore been forced to make difficult decisions about which systems can remain active. Non-essential equipment has been switched off to preserve energy for the instruments and communication systems that remain useful. The spacecraft's age has also created software and hardware problems. Engineers on Earth have had to diagnose faults remotely and develop solutions for computers designed more than 4 decades ago. Yet Voyager 1 continues. Its survival is not simply a technological achievement. It represents an extraordinary demonstration of what careful engineering, persistence, and scientific curiosity can accomplish. And the spacecraft carries something even more personal with it. Attached to Voyager is the Golden Record, a message created to represent Earth and humanity to anyone who might encounter the spacecraft in the distant future. The record contains images, sounds, greetings, and music selected to provide a small representation of life on our planet. Voyager 1 therefore carries two legacies at once: scientific instruments gathering information about interstellar space and a human message traveling silently into the unknown. But its most emotional contribution may have come much closer to home. Voyager 1's journey is not only a story about leaving the solar system. It is also a story about seeing Earth from a perspective no human had experienced before. On February 14, 1990, Voyager 1 turned its cameras toward home for one final series of photographs. The spacecraft was already billions of miles away, far beyond the orbits of the outer planets. Among those images was a photograph that would become one of the most famous pictures ever taken. Earth appeared as an almost impossibly tiny point suspended within a beam of scattered sunlight. The image became known as the pale blue dot. From that immense distance, Earth did not look like a vast planet containing oceans, continents, cities, and billions of people. It looked almost insignificant against the darkness of space. Yet that tiny point contained everything humanity had ever known. The photograph became a powerful reminder of Earth's vulnerability and the extraordinary scale of the cosmos. After completing its planetary observations, Voyager 1 continued deeper into space. Its mission gradually changed from planetary exploration to the study of the environment between stars. The spacecraft was no longer simply observing distant planets. It was measuring the conditions of interstellar space itself. This transition opened a new chapter in astronomy. Voyager's observations have helped scientists study plasma, magnetic fields, energetic particles, and cosmic radiation beyond the Sun's protective heliosphere. But the spacecraft cannot operate forever. Its radioactive power source continues to weaken, reducing the electricity available for instruments and communications. Engineers have responded by turning off systems one by one, extending the spacecraft's useful lifetime as long as possible. Eventually, Voyager 1 will no longer have enough power to communicate with Earth. That moment will be the end of its active mission, but not the end of its journey. The spacecraft will continue moving through interstellar space even after its radio transmitter falls silent. Its path will carry it through the Milky Way for an unimaginably long period. The probe will continue orbiting the center of our galaxy along with countless stars, planets, and other objects. In roughly 40,000 years, Voyager 1 is expected to pass relatively close to the star Gliese 445, although even that encounter will occur across an enormous distance. By then, Earth's civilization may look completely different. The cities that exist today may have disappeared. Languages may have changed. Nations and technologies may have transformed beyond recognition. But Voyager 1 will continue carrying its physical record of the civilization that launched it. The Golden Record makes this particularly meaningful. It contains representations of human life, Earth's natural environment, greetings in numerous languages, sounds from our planet, photographs, and music. It was never intended to function like a modern communication device. Instead, it is a symbolic message in a bottle launched into the cosmic ocean. Its existence raises a profound question. What does humanity choose to say about itself when sending a message into deep space? The answer contained on Voyager is a mixture of science, culture, curiosity, and hope. The spacecraft's scientific legacy is equally extraordinary. Voyager transformed our understanding of Jupiter, Saturn, Io, Titan, and the outer solar system before becoming the first human-made object to enter interstellar space. Its discoveries continue to influence modern planetary science and the design of future deep space missions. Future spacecraft may travel farther, operate longer, and carry more advanced instruments. New propulsion concepts may eventually allow probes to reach other stars far more quickly than Voyager ever could. But Voyager 1 will remain unique. It was created during an era when computers had tiny amounts of memory by today's standards, yet its engineers built a machine capable of surviving for decades and communicating across billions of miles. Its story demonstrates that exploration does not always require immediate answers. Sometimes the greatest achievement is simply reaching a place no human-made machine has reached before and returning information from the unknown. One day, Voyager 1's final signal will arrive on Earth. After that, there will be silence. But the spacecraft itself will continue onward, carrying its golden record through the darkness. Long after humanity has forgotten the exact moment of its launch, Voyager the 1st of May still be traveling between the stars, a small artifact of Earth moving through an enormous galaxy. Its journey began with a rocket launch in 1977. But its destination was never simply Jupiter or Saturn. Its true destination was the unknown.